A student releases a ball of mass, m, without any initial velocity, from a point, O, at the origin of a frame of reference with axis, OY, pointing downwards. Using a camera linked to a computer, the student films the free-falling movement of the ball. For the questions in this activity, draw the graph representing the square of the velocity as a function of h. v square equals f of h. Determine graphically the directing coefficient, k, of the straight line obtained. Compare the value of k with the value of the intensity of gravity, g, which is equal to 10 newtons per kilogram. Find the expression for the work done by the weight of the ball when it falls from a height, h. Deduce that the work done by the weight provides the ball with energy that depends on its mass and speed. To do this, first carry out the experiment. Using the software, AVI Mecha, he plots the movement of his center of inertia, g. What we are interested in here is knowing the ordinate, y, of the ball at each instant, t. For example, at 0.1 seconds, we have y equal to 5.6210 to 2 meters, which is equal to 5.62 centimeters. Here, we have the table of measurements transmitted by the software, AVIMecha, to the software, Regressi. To check that this table of measurements obtained is the same as the one we have just studied with the software, AVIMecha. The values obtained from the two tables are compared. Here you have the curve y as a function of time. Y, as a function of time, is a parabola. The abscissa, xg, of the ball remains constant during the vertical fall. Using a spreadsheet program, Regressi, the student determines the speed of the center of inertia, g, at each instant. Then, the square of the velocity, as a function of h. The answers to the questions in this activity. Experimental measurements have made it possible to draw the curve representing the square of the velocity as a function of the height of fall, h. The directing coefficient, k, of the straight line obtained is determined graphically. This gives us k equals 20 meters per square second. Compare the value of k with the value of the intensity of gravity, g, which is equal to 10 newtons per kilogram. Note that k equals 2g. The expression to work of the weight of the ball when it falls from a height, h, and W of P equals mgh. The work of the weight has given the ball an energy that depends on its mass and its speed. This gives us W2P equals half mv squared. The energy acquired by a falling solid body with no initial velocity is equal to the work done by its weight during the fall. This energy is called kinetic energy, and is expressed by the following relationship. EC equals half m v squared.